Hello, this is Hannah Daly, and this is the last topic in the Sustainable Energy module. The topic is air pollution, and in these couple of short lectures, we'll be covering the main sources of air pollution, focusing on energy-related air pollution, what the impacts of air pollution are, and what the causes, what the solutions can be for air pollution. And many of the slides and the data come from this very good special report by the World Energy Outlook series at the International Energy Agency that was published in 2016, I think. So that's Energy and Air Pollution. If you're interested in doing more reading, that's a free download from the IEA. So some context. First of all, why do we care about air pollution? It's really one of the main causes of global premature deaths every day. Around 18,000 people die from air pollution every single day. That's 6.5 million deaths annually. That is the fourth largest threat to human health. One of the reasons it's not so well recognized is because it's so silent. People die of heart attacks, people die of strokes or pneumonia, and those things can't be directly linked to air pollution. But when health experts, modelers and so on can link people's exposure to their premature death, we can model and understand how many people how many deaths are linked to air pollution. According to the World Health Organization, this is much greater than the number of people who die from HIV/AIDS, from tuberculosis and road injuries combined. So it's really a huge health burden on the planet. The effects are very distributed according to people's status in society in different countries and so on as well. So it's a huge distributional impact as well. So beyond the huge health burden, air pollution also brings major cost to the economy and damage to the environment through people's not working, through erosion of buildings, impact on forestry and crops and so on. Why is this in a sustainable energy module? Because energy production, how we make energy, how we use energy, where we burn energy, the kind of technologies that we use, is the most important source of air pollution from human activity in both developed and developing countries. So basically the energy system is the main source of human-induced air pollution. The main types of energy consumption that cause air pollution are firstly the lack of clean cooking access. Billions of people in the world don't have modern fuels to cook with, so they cook on open fires. That literally causes smoke that they breathe every day. Children breathe, old people breathe, women especially. Causes a huge health burden in developing countries. And again, we can't see it because it's inside people's homes. And the second main cause is poorly regulated fuel combustion. You burn something, particulates, smoke, things like that into the air, which cause different forms of air pollution, and that's in vehicles that move around, in factories, power plants, and these are the most significant sources. And this is across every country in the world almost. Basically, burning fossil fuels and biomass is with old technologies, with unclean technologies, is the second most important source of energy-related air pollution. One thing is that the problem is not automatically addressed as countries get richer. So really big action is needed in every single country to address this. We'll look in later at Ireland as a case study, as well as different developing countries. One thing that's more difficult almost to talk about air pollution than climate change when we're talking about the energy system is that there's a much more complex chain from if we want to explore the causes of air pollution to the exposure and the impacts. The chain is more complex because, okay, we might look at the causes where the pollution is coming from, buildings, factories, cars and so on. The causes cause emissions of different pollutants, but then there's complex interactions between the chemicals in the air. You can have primary and secondary pollutants that transform in the air. How they're dispersed as well matters very much according to their impact, whether they come down in the rain, like as in acid rain, whether there's sunlight or not makes a big difference, the humidity in the air, which way the wind is blowing, and then exposure. And what exposure really means is who is living where the pollution is. Obviously, if we have some kind of emission where nobody lives, where there's no, let's say vegetation that's going to be impacted, then the impact is negligible. But if there's a kind of a very harmful pollutant in an area where a lot of people live, which is very concentrated, this has a much, much higher impact. So it's actually more difficult to measure the linkage between the cause and the impact of air pollution than climate change, because CO2 is burned and then it just goes into the atmosphere, and it sort of has a uniform effect. We know, like a ton of CO2 burned in India 20 years ago has the same effect as a ton of CO2 emitted in Ireland right now, whereas that's not the case for air pollutants. This is some kind of visualization of the different sources, pollutants, different types of affected areas, effects, and atmospheric action that has an impact on climate change. This is just one of many different visuals that you can have. But if you start here with the sources, with the dark images here, well, there are some natural sources of air pollution, for example, volcanoes and area sources. Lightning also can cause air pollution. Fires, industry power plants, mobile sources, including cars, and livestock are all very significant sources of air pollution. There's fertilizer application there in farms, mobile sources like trucks and so on, oil and gas production. These are all different sources. The red here are different pollutants that are formed. The most important ones there are sulfur dioxide, nitrogen oxides, NOx, and particulate matter. Here you get and volatile organic carbon, VOCs. Ammonia there is a strong air pollutant, and these turn into different gases and different particulate emissions that go into the air, and they're somehow transported and transformed. Sunlight, wind, rain all affect how these are transported and transformed, and then how they're deposited. They might be deposited dry as particles, as physical pollution that you can feel. They might be deposited on rain or snow, acid rain, or they can just be in the air and have an effect. The effects then range from people. For example, particulates have effect on the respiratory system, toxins on the nervous system, on the functioning of human bodies. There's impacts on forests, vegetations, and soils. For example, acid rain causes damage to vegetation, on buildings, leaching of minerals from soils, heavy metals in the soils. You can have fish and birds can be affected through the acidification of lakes, for example. Forests can be destroyed. Snowpack can be melted. Lakes can become dead, and so on. Views can be diminished. And the causes of air pollution can range from natural sources, which include just dust, wildfires, volcanoes. As I said, these are all natural sources of air pollution. On a dry, dusty day, there's smoke in the air, or particulates in the air that are not good for your health. But what we're mainly interested in are these anthropogenic or human sources of air pollution. And we can define those into where those sources are. So they can be stationary sources like power plants, factories, especially those burning coal or biomass. Factories and other industrial facilities, chemical plants, mines and oil refineries also are a big source of air pollution through unsettling earth and releasing toxins into the air. Mobile sources, the main mobile source are vehicles. More detail there later. And then what we call area sources, which are kind of focused on different areas. For example, combustion for cooking and heating. Those can be very different. You can, as I already talked about, cook stoves in developing countries, but fireplaces in countries like Ireland are a very big source of air pollution, especially when we're burning peat, coal, and untreated biomass, or like biomass that's not dry, wood that's not been seasoned, in either open fires or stoves which aren't very efficient or good. And then different agricultural practices as well, as I said, can cause air pollution. That's not really an energy source though. We can have other classifications. We can define air pollution as either transboundary or local. So whereas transboundary means that it crosses a bound, literally, that means that it has an origin in one country and it has an impact on another. So if there's a very significant, let's say, coal-fired power plant, and wind carries the pollution across the country borders, that is a transboundary pollution. Local pollution is where the impacts are local to the source. And then we can also classify pollutants into either primary pollution, which means that it's emitted directly from a source. A car exhaust produces nitrogen oxides and particulate matter. But a secondary form of pollution is when it forms in the atmosphere as a result of chemical reactions, either different pollutants interacting with each other, or for example, smog there is when fog, different forms of pollution from in cities interact with sunlight, and then it creates this new secondary form of pollution. We can also classify pollution according to whether it's combustion related or non-combustion. So combustion is where it's produced by burning, again, mainly fossil fuels, biomass or waste, or non-combustion pollution. One example there is, say, from vehicles. There's a significant source of particulate matter from literally where the tires meet the road. There's abrasion, and then particulates from just dust and from the road and the tires get put into the air. So that's particulate matter that's non-combustion related. The main forms of energy related air pollution that we're very interested in here is from fossil fuel and bioenergy combustion. So the energy sector is by far the largest source of air pollution from human activity. Those come from combustion, so at the point of where either electricity is generated or heat is generated, or cars are driving, but also forms of coal extraction and other mining activities cause air pollution, industrial activities, and even the processing or washing of coal. Their coal comes up an awful lot, charcoal production, and also, I already mentioned, the non-exhaust emissions from the transport sector, so tire and brake wear and road abrasion. On the top here we have the 6 main forms of chemicals which are pollutants in the atmosphere, and here are 6 kind of different sources of air pollution. And this is a graph by the IEA from that special report I mentioned, which graphs the energy sources and non-energy sources of these different air pollutions. I'll go through each one by one, but first thing to say is that different energy sectors contribute very differently to the different forms of air pollution. These shares differ according to countries very significantly, whether it's developed or developing countries in terms of absolute quantity as well. It's very serious. And a final thing to note here is that for all these significant air pollutants, the energy sector is by far the largest source, except for ammonia there, where only 3% of pollutants come from the energy sector. The remaining would come from livestock and agriculture production. If you look here as well, what's quite interesting is that the power and industry sector are mainly contribute to sulfur dioxide. Transport largely contributes to nitrogen oxides, and buildings, and that's mainly cooking and heating, which contribute to particulate matter. We'll go through those in more detail. So first of all, the first common air pollutant is sulfur dioxide, SO2. I'll just move myself a bit to the side there. So the main source of that comes from the combustion of fossil fuels which contain sulfur. So 80% of that come from burning coal and lignite, and about 20% from oil combustion, because coal contains about 2% of sulfur by weight, and the concentration of sulfur in coal varies very much from different qualities and geographic sources of coal, and then also how the coal is treated. Heavy fuel oil, which is one particular distillate of crude oil, contains about 3% of sulfur by weight, and heavy fuel oil is often used in industry, in some countries for power generation, and also in the shipping industry. So there's shipping is the fuel kind of consumption is very under regulated. So if you're in any kind of port town, you'll feel a lot of air pollution in the air from the ships, from the sulfur in the ships. In 2015, the energy sector was responsible for about 80 million tons of sulfur dioxide. So nearly half of that came from industry, and a third from power, and a quarter of that was in China, the next largest from India. So in countries, big developing countries like China and India, where coal is increasingly used for big power generation, big industry, this is a very, very serious pollutant that affects health environment and economies. So the main kind of pollutant that or impact that we are familiar with from sulfur dioxide is acid rain. So when SO2 gets dissolved into water vapor in clouds, it produces acid rain, which has very harmful effects on plants, aquatic animals, and infrastructure. Here, for example, that's an alpine forest. Often high up forests suffer the most from acid rain because they're in the clouds, and the clouds just contain more. They're affected more. Inhalation of SO2, of sulfur dioxide, also narrows the airways. That's called bronchoconstriction, which people suffering from asthma are much more more sensitive to. And different studies have looked at the location of even young children's schools and their prevalence of asthma, and that's very, very much related to sulfur dioxide concentrations in the air. Just so an article in The Guardian today that a high court actually blamed air pollution on one girl's death, a 15-year-old girl who died of an asthma attack. So, it's actually, it really does exacerbate any conditions like that. It also is a strong irritant of the eyes and of the airways. SO2 emissions vary very significantly by region. Again, there China and India were the biggest regions in terms of source. India, there more than half comes from power, but in China, most of the sulfur dioxide emissions come from industry. You might be familiar with different sources, but no country is immune. Here in the EU, a significant source comes from buildings. I suppose that's from burning coal and oil use as well. Africa as well is growing significantly too. The next most significant air pollutant is nitrogen oxides, NOx, which are either nitrogen dioxide or different forms of nitrogen oxides. The main source there of nitrogen oxides is actually the transport sector. And the sources of nitrogen, of NOx emissions, they're both a primary pollutant in that they are produced by combustion, mainly from the transport sector, but also industry and power, but also as a secondary pollutant by different processes, chemical processes in the air. As I said, it's produced from motor vehicles, so concentrations are higher on busy streets where there are people living. So, in the case of sulfur dioxide, there can be technical fixes where you move the factory out of town. You have a very high smokestack, so the sulfur dioxide goes away into the atmosphere. But when there's a mobile source that is necessarily where the combustion is close to where people live, it's much more difficult to mitigate in that kind of way. So there's distinct daily variations in NOx emissions, which peaks with traffic levels when you're sitting, especially with a lot of diesel cars that we have in Europe. If you're sitting in a street with high buildings, you can really feel that in the air. It's very unpleasant. Cold and still weather increases the concentration due to that trapping of wet air close to the ground. That weather also increases other local pollutants. Gas cookers in homes can be a source of NOx emissions. More than 99% comes from the energy sector, mainly transport and industry. So more than 100 million tons of NOx emissions were emitted in 2015, mainly again from China, but also from the US, because the transport share there is very different. Again, NO2 is an irritant gas, and also, like sulfur dioxide, causes narrowing of the airwaves in asthmatic and non-asthmatic individuals. One of the secondary effects of NOx emissions is that it contributes to the formation of fine particulates, which is a big cause of premature death, actually, and it increases the prevalence of asthma. If we look at the regions and sectors which are responsible for NOx emissions, again, big developing countries, China and India, are very significant, but it's really much more prevalent in the EU and the US and other advanced economies, because we have such a high share of transport in our final energy consumption. Here we have, in the EU, more than half of NOx emissions come from transport, but also industry is a very significant source there in China, again, as well as other sectors and power. The third pollutant that we look into in a lot of detail is particulate matter, PM, and we usually talk about either PM 2.5, which is very fine particulate matter. It's more than or less than 2.5 micrograms. We also talk about PM10, which is particles of around 10 micrograms. and anything less than PM10 is associated with health effects. So these are any kind of particles, just tiny bits of dust in the air that are very, very small. And actually, the smaller the particle, the more grave the health impact, because they can penetrate deep inside the body, and the body's natural defenses can't filter them out. So larger particles bigger than 10 micrograms in diameter can be filtered out by the body's natural defense system. You cough it out and so on. But it's those small particles, PM2.5, that we really care a lot about, because they reach deep into the lungs. They can be absorbed by the bloodstream, and they can cause lung cancer, lung problems, pneumonia, and other health problems. And actually, I think that a lot of the health problems that come from air pollution are just being investigated, and we don't know the full extent. So more than half of that comes from the residential sector. So burning biomass and coal for cooking and heating, but also burning kerosene for lighting, because in places where there is no electricity access, you have to literally burn candles or burn kerosene for lighting, which also causes significant indoor air pollution. PM also comes from the transport sector. Again, especially from road abrasion, things like that. I suppose that's counted under other and industry. So any place where there's burning of coal, biomass, solid fuels, peat as well in Ireland, it's a very significant source. If we look then at the regions, here what really pops out is Africa. From the energy access lectures, there's very low access to energy in Africa, as well as India, different parts of Asia. And so it's really the building sector that contributes very, very strongly to PM2.5. And it's a very significant source of premature deaths in those regions as a result. Just a few other pollutants that we can talk about briefly. Ozone, it's 3 oxygen particles. There's 2 forms of ozone. There's this sort of ground level ozone, which is created by different pollutants, but there's also atmospheric ozone. You might have heard of the ozone layer. That's something that we actually really need to defend against radiation from the sunlight. And you might have heard of this hole in the ozone layer that caused skin cancer and so on in the southern hemisphere. Luckily, that hole in the ozone layer is being solved, thankfully. But ozone created a ground level contributes to smog and other negative effects like that. And it's actually a secondary pollutant caused by chemical reactions between NOx and volatile organic compounds. Another form there is carbon monoxide. That's carbon with 1 oxygen atom. Hopefully you have carbon monoxide detectors in your home if you're burning any solid wood, because it is it's a silent killer. It bonds to hemoglobin, which carries oxygen around the blood, and it actually impairs the oxygen carrying capacity of the blood. So the main source of indoor carbon monoxide is incomplete combustion of solid fuels. So where there's not enough oxygen, if you have a poor stove or an old gas-fired hob, and a severe carbon monoxide poisoning can cause death. It's very significant. Third pollutant there is lead, which is a heavy metal naturally in the Earth's crust. Previously, lead was part of petrol. We now, almost every country in the world only uses unleaded petrol, but even low levels of exposure to lead impairs brain function and affects mental development of children. It's really a very significant impact on childhood development. So we went through the main sources and causes of air pollution, air pollutants, but going back to the first flow diagram, what matters is not just the sources and the types of emissions, but how they're concentrated and where they land. So the negative impacts of air pollution are not just about emissions, but concentrations and exposure. Concentrations means how dense they are. Whether if it's a windy day and they get dispersed, they have much less impact on it, whether if they're in just one concentrated area. And what determines concentration is not just the amount of pollutant, but the concentration of where that's coming from, which is determined by the type and scale of the local economy, the population size and density, the energy mix, the strength of local pollution regulation, and the geographic and meteorological conditions. Lived in Paris for a number of years. Paris is infamous for air pollution. If you kind of climb up a skyscraper, you can see this horrible grey fog on the horizon. And that always comes because Paris is essentially a city in, surrounded by hills. It's like a bowl, so that geographic conditions, and especially it's often very still weather there, it's not too windy, it creates this just bowl of air pollution that's horrible, especially when there's such a large amount of cars in the city. What matters as well is the lifetime of pollutants. So different pollutants can have different lifetimes. They can have a lifetime of a few days or for many centuries. And the kind of time scale of pollution and the pollutants themselves lead to high concentrations. So again, that's like transport emissions spiking at rush hour, particulate matter episodes happening in still days and cold still days in winter when there's a lot of, let's say, fires happening in people's houses. Ozone episodes. Ozone is created from NOx interacting with sunlight and different compounds, and so ozone episodes happen mainly in the summer.